Okay, we have a sample problem here. I have 100,000 joules of energy that's added to 500 grams of water at 20 degrees Celsius. Your goal is to find the final temperature of the water. So if we add energy to this water, it's going to increase its temperature. So let's draw a heating curve of this situation. My initial temperature is 20 degrees Celsius. That's what the temperature of the water is going to start out as. Now, you have to ask yourself, what's happening when we add the energy? Is the water going to boil at 20? Is it going to warm up? Is it going to freeze? What is it going to do? In order to answer that, you need to know what the melting and freezing point, as well as the boiling and condensing point of water is. Well, it melts and freezes at 0, boils and condenses at 100. So that doesn't happen at 20. So that energy is going to heat up that water. To what temperature, we don't know. That's the whole point of this problem. That's what we're trying to find, the final temperature. So we have the sample of water. It's heating up over time. We want to find the change in temperature in order to find the final temperature, because our change in temperature is going to be the difference between our starting temperature and our final temperature. So you got to ask yourself, what equation do we want to use in order to calculate delta T, our change in temperature? So you can look at this flow chart. Ask yourself, do you have a temperature change or a phase change? Well, we should only have a temperature change going up. So that means we use Q equals mc delta T. Q is the energy, M is the mass, C is the specific heat of whatever sample you're using, and delta T is going to be your change in temperature. So we know we're going to use Q equals mc delta T. And we have to solve for delta T. Do we have a Q? Well, yes, we do. 100,000 joules of energy. Do we have a mass? Why, yes, we do. 500 grams. What about this little c? Well, you have to ask yourself, what are we heating up? We're heating up liquid water. So we need to use the specific heat of liquid water, which is 4.18 joules per gram degree Celsius. And we're trying to find our delta T. So we don't know what that is yet. We do know our initial temperature, but that's not our change in temperature. That's just their starting temperature. So in order to find delta T, we want to get delta T all by itself on the right side of the equation. That means we have to move 500 and 4.18 over to the left side. Now this is when your algebra skills kick in. What you do to one side of the equation, you have to do to the other side. So if we want to move 500 grams over, we have to divide both sides of our equation by 500 grams. If I want to move 4.18 over, I have to divide both sides by 4.18. So 500 divided by 500 is 1. That's going to cross out. 4.18 divided by 4.18 is 1. That's going to cross out. We're left with our change in temperature is equal to 100,000 joules divided by 500 divided by 4.18. So in your calculator, you're going to put 100,000 divided by 500 times 4.18. And notice how I put parentheses in that? That means that I'm dividing 100,000 by this entire section. That's equal to around 48 degrees Celsius. I'm going to round up. So our change in temperature is 48 degrees Celsius. That is not my final temperature. That just means that when I started out at 20 degrees Celsius, the temperature changed to 48 degrees Celsius, or changed by 48 degrees Celsius. So you have to start at 20, we're changing by 48 degrees, so that must mean my final temperature is 48 plus 20, which is 68 degrees Celsius. That's my final temperature, 68 degrees Celsius. And then you're done.